Hello and welcome to the practice problems video on evaluating limits algebraically. Okay, so for this problem, we're going to find the limit as x approaches 5 of 2x squared minus 9x minus 5 all over x squared minus 25. So first of all, let's just try plugging it in. So f of 5, so this again, this is our f of x, right? So here's our f of x, and if we plug in that 5 right away, we see that we have 2 times 5 squared minus 9 times 5 minus 5. And this is all over 5 squared minus 25. And this will actually turn out to be a, so 2 times 5 squared, 2 times 25 is 50, minus a 45 minus 5, that's a 0, over 25 minus 25 is also a 0. So this here is our indeterminate form, okay? So I'll just write indeterminate, okay? So what we have to do is play around with this, apply some algebra, and get f of x in a different form so that it is continuous at 5, okay? So let's see what we can do. So limit as x approaches 5. So the top and the bottom both look like they could be factorable, possibly. The bottom definitely. So let's see about the top. So we could have a 2x times something and an x minus something or plus something. So this is actually going to turn out to be, because we want that negative 9 there, so we're going to have a minus 5 here and a plus 1, okay? So that's the way the top will factor, and then the bottom factors into x plus 5 and x minus 5. Okay, so see here how we basically just factored. That's it. This is our same f of x, but what we can do is cancel the top x minus 5 and the bottom x minus 5. And in doing so, we remove this discontinuity of f of x, or also known as the indeterminacy of the limit. Okay, so now let's rewrite it without those x minus 5. So we have limit as x goes to 5 of 2x plus 1 over x plus 5. Okay, so now we see that this form of our f of x, this is still our f of x, okay? This form is continuous at x equals 5. So let's just plug that in. So all we have to do is 2 times 5 plus 1 over 5 plus 5. So we get 10 plus 1, that would be 11, and then over a 10. Okay? And this gives us a determinant form, or a determined form, which doesn't involve zeros or infinities. Okay? So that's it for that problem. Now on to the next one.